So hello and welcome. We are happy you could join us. And I do hope you're having a dry day. Now I know some parts of the world are in drought conditions, but here where I am in the northeast of the United States, we've been seeing rain almost every day for what seems like weeks. It's been at least 10 days, but I digress. I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. Now, today's DevOps.com webinar is brought to you by Gremlin. And I have with me Jason Yee, Director of Advocacy at Gremlin. And he will be speaking on disaster recovery. So, Jason, if you could please introduce yourself to our audience.
Yeah. Hey, everyone. I'm Jason Yee. As mentioned, I'm Director of Advocacy at Gremlin, which means that I have the amazing opportunity of having a job that's really all about helping educate people about reliability. So that's why we're talking about disaster recovery today.
All right. Thank you, Jason. And I know he's eager to get into giving you background on the best practices for creating a disaster recovery plan and on how to test your plan against unforeseen events, that is, black swan events, by using chaos engineering. However, I must take care of the housekeeping items first. So, Jason, you'll have to hold on for just a few more minutes. Now, please note that this webinar is being recorded so that it can be available on demand. Now, you will receive an email with the link, but at any time you can go to devops.com to gain access to all of the archived on-demand webinars. Please avail yourself to those educational webinars whenever you have some free time or educational time. Now, a few comments on the big marker platform we use. On the right-hand side of the screen, you'll see the chat button. This feature allows everyone online to comment on today's event. Say hello. Let us know where you're located. Feel free to comment on anything that is going on in the chat and in what Jason is speaking about. We love the immediate feedback, and we do want to hear from you. Now, for questions, please don't use the chat window, but instead click on the Q&A tab, which is directly to the right of the chat tab. Now, we'll try to answer as many of your submitted questions as possible before the end of today's session. However, if we're not able to get to them, Gremlin, I'm sure, will follow up with you. Now, one of the most important items to the webinar, I'm sure from the audience points of view, is at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you are selected. So now it's time to jump into today's session with Jason Yee. The floor is now yours, Jason.
Thanks, Charles. Cool. So let's kick this off with a little bit of a question here. So as Charles mentioned, there is the chat panel to the right. So I want you to think about this. How much confidence do you have that your existing disaster recovery plan works? So go ahead and post that in the chat. If you have a plan, let us know how confident you are. If you're confident, if you're not confident, or maybe you don't have a plan. And that's one reason that you've joined us today, is to start thinking about that. So go ahead and post that into chat. I'll give you a brief moment to do that. 62%. That's a very specific number, Ajoy. But that's a pretty good number. Don says that he's very confident, and that's fantastic. So we're going to be chatting a little bit more about how to get more confident in our plans. And I think as we discuss this, as we think about this, when I chat with people about their plans, oftentimes I get people that they're talking to me simply because they're not confident in it, right? Or they're confident, but there's always this very, this small voice in the back of their head that says, maybe, I think everything should go as planned, but maybe right? Maybe something would go wrong. What have I missed? And I think as we think about disaster recovery planning or disaster response planning, it often is flawed, and that's often for two reasons. And the first is that I think that DRP is inherently reactive and not proactive, and that it assumes that a disaster happens and then plans a response, right? That whole idea of having a response is inherently reactive, and that's not necessarily bad, but I think the way that we approach that and the perspective of a response plan puts us in a negative mindset that we're always going to be in that reactive mode. So I'm going to talk a little bit about that later and how we can overcome that. And the second is that I think the severity of a disaster, when we think about DRP, we're thinking about major catastrophes and how we can respond to those. And by focusing on major disasters, right? The outage of a data center going down due to a hurricane or an earthquake, if we think about it in that way and we constrain ourselves to that, it affects how we think about incident response and responding to things. And it misses a whole category of other incidents that will come up that affect how we build up reliability. Charles gave me a fantastic introduction, so I'm not going to go over my bio slide too much, but I did want to point out that I'm available on Twitter. My email is here. So if you have any questions, if you're thinking about this, and we'll have some QA time later, but maybe you start thinking about things over the course of the day or even this week, and you suddenly have a question, feel free to reach out. As mentioned, my job is all about education and helping people, whether that's using Gremlin or chaos engineering or just general reliability practices. So don't hesitate to reach out. I'm always available to help. That said, I do work at Gremlin. Gremlin is a company that's focused on helping you build more reliable, resilient software and processes and systems. And the way that we've done this is we help you with a chaos engineering platform. So we've built a platform that lets you safely inject failure into your systems so that you can learn from it. There's a bunch of information on our website. We actually have this great ebook that was published by O'Reilly. It's available for free from this link, and it's all about reducing the mean time to detection for high severity incidents. So really applicable to what we're talking about today. So I'll let you quickly screen capture that. We'll also post the links later. So if you're in the midst of trying to type this out or copy it down, don't worry, we'll send that out in a bit. But on to the topic at hand, right? So maybe I just said, I think that DRP is flawed because it's reactive and not proactive. And I know a lot of people immediately respond to me and say, but I'm creating a response plan ahead of the disaster, right? Isn't that proactive? And my response to that is, in a way, but generally no, right? You're still creating a reactive plan. Because in reality, we don't have binary operations. We don't have this binary state of it's operational or it's disaster. It's sort of this gradient or this spectrum that runs from minor annoyances, things like suboptimal performance, that we often just overlook because there's a certain allowable amount where if our users have maybe not the best experience, but they're still able to do the things that they want to do, then we generally sometimes overlook those. And then those lead to minor incidents and medium incidents and severe incidents before finally getting to catastrophic disasters, right? And so if we think of things as this range, we can start to open ourselves up to thinking, well, what does proactivity mean? Rather than just a plan for when those major incidents happen. So when those hurricanes hit or those earthquakes hit, or we lose data centers, what happens a little bit before that? Because proactivity doesn't mean addressing the plan earlier before disaster. I think it means broadening our plans, broadening our scope to encompass the fuller range of incidents. I think it means that creating plans and processes and reliable cultures that address incidents when they're minor, when they're medium incidents, that sets the stage, that sets the trajectory of our teams and how we respond and the values that we hold. And we can take those from those small incidents, those small moments, and they allow us to be prepared for the big ones. So that it's not just, I'm following a plan, I've got a checklist, right? It's now something that's ingrained in our teams. And it's a scaled up incident, but it's not a different response. It's not a different sort of reaction that we rarely get to exercise or do. So if we take a look at what things look like now with being reactive, and this applies even to those smaller incidents, we often just think about things like logging. Do we have the right logs in place? And we've got plenty of tools that allow us to ingest the logs from our applications, and that helps us understand, or we have data that we can look at. And often that's, our response plan for a major incident is, well, let's look in the logs and search for those things that we need. And then we can get a little bit more proactive by monitoring and having alerting, right? We can start monitoring metrics and alerting, but that's still a bit responsive, right? We're starting to look at those metrics and trying to anticipate things, but it still puts us in a very reactive spot. We also see this in the incident response process itself, right? When we have an incident right now, even great teams are still being reactive because you've got a defined response plan, right? What's your incident response look like? Maybe you follow the PagerDuty model of incident command. And then we're starting to try to move from that reactive state to maybe a proactive state, to applying what we've learned. So we start to look at blameless retrospectives or post-mortems. How can we learn the most from our incidents? And then we end up cycling that back, right? We complete the loop and we have a follow-up. We take those learnings and we try to make our plans better. But I think really what we want to do and what the goal of learning is maybe not exactly the details of what we're learning, but it's building a larger culture of reliability. So that rather than having a specific set of rules or a singular process for disaster recovery, it starts to become part of everything we do. It's just how we work. And I think that naturally leads to SRE, site reliability engineering. And this is something that's become popular in our space, right? And I think it's become popular for maybe some wrong reasons. One of those wrong reasons being that it was started at Google, and Google's known for having written a lot about this and talking about reliability and things like that. And so a lot of people are saying, well, let's do SRE because Google does it, right? Or let's do SRE because per Google's implementation, SRE is their version of DevOps. And so everybody wants to do the DevOps, right? So there is a ton of resources here, and I think it's great, but I think we need to move beyond it's just DevOps or we do it because Google's doing it. I think we need to, if you haven't read these books, you really ought to read them. They're freely available online. But we need to get to the core principles of what SRE is. And again, I think this helps us build that culture, and it really shapes the way we start to do disaster response and recovery. And the first principle of SRE is really ownership and collaboration. Within the model of SRE, people often think of SRE teams as their own thing, but really the model of SRE that's proposed from the original book is that service teams own their services and they work with other service teams. And then SREs are embedded into that service team. It's not a separate team. So every service team has somebody whose main goal is the reliability and operation of that service. This allows you to have teams that now, rather than relying on somebody else, rather than saying, we're going to write it and we don't have to think about how we're going to ship it or operate it, now there's that ownership, right? They own their service from conception and building through deployment and operation. The other part of this, though, then, is the understanding that failure is normal. Nothing is perfect. Everything operates in some sort of state of failure and with tons of risk of something failing. And it's not always your own application or service. It could be your cloud provider. It could be being reliant on a dependency, right? And if that dependency goes down, how does that affect your service? But understanding that failure is normal means that you can start to balance reliability and innovation with an attention to the customer experience. And so that balance now is up to the service team. And because they have ownership, they're allowed to start defining that with the understanding of what a customer needs, what they're able to provide, and how much time and resources that'll take. The other part of failure being normal is learning from that failure. You know, I mentioned blameless postmortems, but the whole point of that is that blame doesn't lead to solutions. It encourages people to hide flaws, hide their mistakes. So by being blameless, it means that we can focus on what actually happened, right? We don't have that impetus or that fear of retribution that would cause us to hide what was done or to hide data. We can now bring that to the forefront and say, look, this is what happened. This is the information that was missing and what we needed to make a better decision. How can we expose that? The third principle is iteration and automation. Small changes obviously reduce risk and they're easier to deploy, and automation helps us reduce error and speeds up those deployments. As we start to adopt this, it makes it a whole lot easier when we're starting to think about disaster recovery, because if we're introducing small changes with fewer risk, it starts to build up our confidence. And it also, because we have this velocity, it allows us to recover faster when we need to. The last SRE principle is to measure everything. We often think of this as systems and processes, right? And that's a very clear one. We measure our resources and our infrastructure. We measure latency in our networks. But we also want to measure our processes, the people side of things. How long does it take us to accomplish tasks? This helps us find those blockers. And again, as we start to think about disaster recovery, this informs how quickly we're able to respond. And I think it's a good point of bringing up, again, I'll share the link later, but that link that I shared before about the ebook, finding ways to decrease that mean time to detection and improve our ability to respond. Just to hammer this home, though, I love this quote H. James Harrington wrote, and it's been paraphrased many times, but he said that measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. And if you can't understand it, you can't control it. And if you can't control it, you can't improve it. So measurement is key, especially as we're building up a culture of reliability and starting to work on the small incidents to prepare ourselves for larger ones. Measurement is so important that it forms the foundation of what's been called the Sre Pyramid. And this pyramid really is the areas that we need to master in the order of their importance. So at the bottom, the foundation of this, the foundational skills that we need are monitoring and observability. We need to have those tools to monitor the state of our systems and our applications. This allows us to set things like service level objectives and service level indicators. Service level objectives being the level of service or performance that we're setting as a goal, and service level indicators being the metrics that we're going to watch that make up that goal. And all of this helps us to define then an error budget, and that's the amount of time that we're going to devote that we're okay with having maybe unoptimal performance, right? It's easy for management to say, well, we don't want any unoptimal or suboptimal performance. But obviously, again, if failure is normal, if it's inherent in our systems, we're always going to have something, and it could be outside of our control. So we need to decide how much resources we're going to spend on that. And setting up an error budget for you and your team will allow you to do that. It also allows you to experiment, though. And as you're able to experiment, you're able to make improvements without fear of negatively impacting things. And one way that you can do that then is use that to test your DRP. And I'll talk about that later. The next level up in the pyramid is incident response. And this is the incident response process includes your on-call rotation and your response processes and how you define incidents and their severity, how you escalate them, how do you communicate them throughout an incident. There's a lot to get into here. So I'm not going to cover this in too much depth. I highly recommend that you check out the incident response process from the folks at PagerDuty. You can get that at response.pagerduty.com. But this is traditionally where your DRP lives, right? It's, again, a response plan. And so a lot of what PagerDuty has in their frameworks and how to run that process will really apply there. Post-incident analysis is next in the pyramid. And as I mentioned, this is the focus on learning. You don't want to point blame. You don't want to know who did something, but you want to know what happened and how did you detect it? How did you respond and how long did it take you to respond? And ultimately why it happened. What were the factors that led to this? And then coming up with those action items. After those foundational layers, the pyramid moves more into development, architecture, and design. And I won't cover too much of these because I think it starts to stray a little too far from the DRP topic. But I will say that how you design and develop your application plays a significant role in how reliable it'll be. And it also has some contribution to how you respond to things. Right? If you architect an application for failover, it makes it much easier to respond to disasters. But I'll leave you the link to these books. I highly encourage you to read them. A lot of folks are just taking SRE and trying to adopt it based on what they've heard in, well, webinars like this, or random blog posts around the internet or conference talks. Having read the books, they're fantastic books. You should read them. Go straight to the source. But I've been saying all this stuff about building a culture of reliability, right? And for better or worse, sometimes as engineers, we're like, culture schmalter. Like, is it all just touchy-feely? Like, how does this actually help prevent disasters? How does it help in recovering from disasters? And I think part of it is that if you're building up a culture of reliability, if you're building a culture that's blameless, if you're putting in place the tooling to focus on observability, to focus on learning from your small incidents, it helps you with your large incidents. And it also makes you open to things like chaos engineering. Because chaos engineering allows us to test things. It allows us to not have to wait for disasters to strike in order to find out if our plans work. It allows us to not have to do mental exercises of let's pretend and imagine what would happen, but we can actually start to test things as they would happen in the real world. It allows us to test our SRE practices and our incident response. Now, you may have heard of chaos engineering before, and you may think, well, how does randomly destroying things actually help? And I think the number one thing to pull out of this from chaos engineering is that it's not random. If you've heard of Chaos Monkey and a lot of the tools that randomly took down servers, I want you to forget about that. Chaos engineering, as defined, is thoughtful, planned experiments that are designed to reveal the weaknesses in our systems. Because by knowing about the weaknesses in our systems and in our processes, we're able to improve them, make them better. And this is critical when it comes to responding to a disaster. We want to know where our systems are going to fail us before that happens, not during that disaster response. So the process is quite simple. I've boiled it down to 4 steps, right? But it's basically running a science experiment. You create a hypothesis. So thinking of under this set of conditions or this type of failure, I think my application will do this. I think that my response plans will lead to a certain type of resolution. So then you run the experiment. You create those conditions or that failure, and you verify if your application behaves the way you think it should or you thought it would, and that your processes actually work as expected, or that all the steps are detailed in your plan. So many times I've seen people try to test their plan and they realize that it made a lot of assumptions that weren't actually detailed in those steps. So these are good things to learn, and that's where the learning comes in, is the analysis of that data. Oftentimes, our systems won't behave how we expect. That's the nature of complex systems. And these surprises can cause the biggest issues during incidents. Those missing steps in that plan can cause people to assume the wrong information or do steps that weren't accounted for, and they can make things so much worse. So having this information then allows us to improve our systems, to ensure that things don't go sideways. And from there, we can share what we've learned and we can iterate. So if we remember that principle of iteration, one of the things about this is to start small, right? We talked about that before. We want to start with our small incidents, how to respond to those, and then use those to iterate up, right? And that's how we get better disaster response and recovery plans. It's starting with the small ones. And the same thing happens with chaos engineering. If we start small, the smallest test that will yield a signal, a result, then we can take that information from that signal or that result and then improve it. And then we can increase. And then by doing that, we can ensure that we can survive, for example, a single server outage. And we can experiment on that before working on an entire cluster outage, and then building up to a data center or an availability zone or a region, or even an entire cloud provider. And we've got customers that are doing just that. They're testing what happens if one of my cloud providers goes down. How do I fail over? So as we think about proactivity and chaos engineering, there are levels, right? We want to start with those infrastructure failures. What happens when a server goes down? And then we think about localized failures. And then we can even start to think about external failures. And this is a thing that I think often disaster recovery misses, is what are those external failures, right? Maybe I'm not based out of the Southeast in the US, so I don't really care about hurricanes. But then a hurricane comes and it wipes out a data center, and I realize that, oh, I was relying on a third-party service. And that third-party service, their data center was there. So we can start to become more proactive about this and level up, not just growing our own from internal systems, that what that blast radius looks like or what those systems that are affected are, but starting to look externally. The other question that I get about chaos engineering is, this sounds great. I've heard it's done in production, right? Again, thinking about Chaos Monkey, it was just randomly destroying servers in production. And that sounds a bit scary. And I always mention to folks, though, that just like you do with anything else in your development flow, you don't start in production. You start in development, and you work on things there, and you build confidence, and then you move to a staging environment. And again, you build confidence before moving to production. Ultimately, though, you're going to shoot for production, and you're going to shoot to be even more proactive and roll this into your automation, right? Rather than let's test things and be proactive in a manual sense, how can we be proactive automatically so that every deploy, we're starting to test what failure looks like and ensure that our response works, especially those automated responses. But ultimately, we do need to push for that production chaos, that production failure testing. We need to know what it looks like, because staging is never exactly like production. Even if we match everything up correctly, it's not where our customers are. So it never has that real traffic. It never has those real conditions. We can think of this often like our backup systems, right? We've often heard that no backup is truly a backup until it's been verified, until you've actually run through the process of pulling that information and trying to restore it. And it's the same thing with all of our systems and with our plans. If we're not testing things, if we're not causing failures and responding to them in a production sense to see what happens to ensure that our plans work, then our plans are useless. So if we think back to that Sre Pyramid, and we think about how does chaos engineering apply as we're starting to develop our reliability, our culture of reliability. Well, chaos engineering is often thought of as just failure injection, but it can work with so much more, right? It can work by validating our monitoring, not just taking down our systems, but like, if I inject failure, I should be able to see that within my monitoring tools. When I worked at Datadog, it was extremely common to talk to customers who said they had an outage or an incident, and their dashboards never showed it. And obviously, working at a monitoring company, they were like, well, your application doesn't work. It didn't show me the things that I needed. And it was, well, the application works, it's just your dashboards weren't set up correctly, or you were looking at the wrong metrics. So this is the first thing that we want to do as we're coming up and think of coming up with our plans, our response processes, thinking about, do we have the right data at hand? And so one way to do that is to cause failures and test our monitoring and observability and our alerting. Then when it comes to the incident response, again, testing that alerting, but also testing our on-call rotation, our pager duty. Did pager duty work? If one of our engineers didn't respond in time, did it fail over and notify that secondary on-call engineer? It also allows us then to run through that response process. And again, this is traditionally where DRP sits. So if we cause a failure, can we start to exercise our plans and our processes and test that they actually work the way that we think they do? We often call these game days or fire drills, really just a way to simulate an incident or a disaster to test our response. But it is a good reminder, especially when you call them fire drills. We often do this in the real world for disasters. We practice the idea of, we're going to test those fire alarms to ensure that they work, that everybody's notified if there's a fire in the building. And we test the idea that we're all going to exit in a calm and orderly fashion, and then we're going to meet up somewhere, and we're going to ensure that everybody's out of the building. And so as we think about our disaster response, we want to do this as well. How often are we testing this? Can we inject failure in a controlled way and calmly walk through the process so that should a real disaster come, we can respond with lower stress and with clear heads? And then when it comes to our post-incident analysis, we oftentimes think about, cool, we've survived the disaster. We run an analysis on what went wrong in our systems. We come up with some tickets, some action items on what we're going to do. And then we're done, right? That's it. We've fixed the thing. And rarely do we go back and actually validate those. We'll often write new code, or we'll make updates to our applications, and sure, they'll have, unit tests and maybe some other testing in there, integration tests. But do they actually solve for those incidents? So we need to go and test them again. And again, chaos engineering is fantastic for that. If we can recreate that incident, we can ensure that whatever we came up with to fix it or resolve it or make it better actually works. As I mentioned, the pyramid gets pretty deep. It gets into a lot of the design and architecture. But after those foundational layers, we can start to look a little bit more about how we can use chaos engineering to really start to test and validate our design and our architecture for our applications. So a lot of this, the planning and that feedback loop sounds a lot like the typical software lifecycle loop, or that DevOps loop of planning and then coding and deploying and operating and having that feedback into our response and planning and updating our code. Intellix, which is a fantastic analyst firm, came up with this idea of the DevOps bubble, and they've really taken a look at how chaos engineering can be applied to all aspects of the software lifecycle. I had fun with those folks and coming up with this concept. If you want to see the larger image, that's available at this link here. So made that a bit.ly so it's a bit shorter. So let's get back to DRPs. What does it look like for chaos engineering specifically with your response plan? And I think the idea here really is to take your response plan, if you've got one, and start to create experiments for that. And if you don't have one, then the idea here is to experiment and get better at your typical response. Figure out how you would respond to small incidents and then start to scale them up. So as I look at response plans, you probably can't, this is the one from IBM that they published. You probably can't order a mobile command center on a truck like this IBM plan calls for, but you can absolutely run an experiment to test a region failover, right? You can run an experiment and cut off a region and work on how you would respond, and does another region come up? Or you can test for cloud failovers, and you can test your incident response in command. Or you could just wait for disaster, right? That's your only other option, is to plan and hope that things work right, and then the disaster comes along. But disasters are when things go wrong unexpectedly, and it's not that there was an earthquake or hurricane. That's not the disaster. The disaster is the disrupted service in an unexpected way. And that inherently means that when you deal with them, you're going to encounter unexpected things. It's the nature of disasters. So plan for them. Practice your response. Uncover those unexpected things before it happens. Does it work? We've worked with a bunch of companies that have done this. Qualtrics is one of them. Qualtrics makes software that you'll often see. It's the little pop-up chat bubble that connects you with support people, helps you pay your bills online, things like that. They've actually been testing their disaster recovery. They went service by service. They planned regional and cloud failovers. They were able to save huge amounts of time. They worked with over 40 different service teams to do this. So this case study, as well as many other case studies, are available on our website, gremlin.com/customers. We've been partnering with a lot of companies in order to do this, to plan for disasters, especially as our world seems to be becoming more and more prone to them, whether that's natural disasters or the recent rise in things like ransomware attacks. What happens when you get locked out of parts of your systems? But ultimately, the way that we can respond to this, the way that we can get better, is to build a culture of reliability and verify it. Verify everything with chaos engineering by actually creating those hostile environments, by actually creating those degraded conditions. If you want to learn more about reliability, we've got plenty of information at gremlin.com/reliability. And with that, I'll open it up to questions. There's the link again to that book, Reducing the Mean Time to Detection. And as mentioned, there is a recording of this. So for folks who want to review things, you'll get that email from the fine folks at devops.com shortly.
Great, Jason. I was going to ask you to put that link up, but I see you already have that built into the into your presentation, so that's great. I picked up a few nuggets of information, and just before we get into questions, I kind of think one of the hardest things for people to accept is failure, right? So when you say failure is normal, they're kind of like, ah, they don't like that, right? We're always striving for perfection, but we kind of find out that if you strive for perfection, you might even make more mistakes, right? So,
Absolutely.
blameless evaluations are important. And I'd like that concept of the error budget. I don't think I've ever heard that. And I come from the security side, not so much the software side, but I can see error budget as being something that comes into play with security too, because it allows, as you mentioned, for that experimentation. Let's see, do something a little different, and that's obviously what chaos engineering is all about. And on the security side, I think we call it fuzzing. It's chaos engineering and fuzzing might be very similar, but I'm getting off subject. So I want to get to some of the questions, and Mike has some really timely and thoughtful questions. So let me jump into the first one. And his question is, he's continually asked, or is continually asking companies who have DRP on why would any of them pay ransomware, right? So the ransomware attack, to a certain extent, is a failure of the IT system because, do you not have a disaster recovery plan? Do you not have backups? So do you have any comment about that on how the rise in ransomware is impacted on either the IT system or DRP in general?
Yeah. I mean, I think of it the exact same way. So I'm glad that we're both on the same wavelength, that ransomware, if you lose access to a system or to some data, that's a disaster. It's no different than if you'd lost that storage facility due to a hurricane or an earthquake. You should have those backups. Now, in terms of the original question, should people pay it? I think, that really depends. I was recently listening to an NPR article, and they were interviewing the CISO for a company. And it turns out for them, the cost of time for the ransomware attack of actually recovering things, because it was so widespread, they did the math and they were just like, it's just cheaper to pay this, which is awful because you're just encouraging more of that. But I could see from a business side, when you're an executive and you're just running the numbers of what's cheaper for me, what gets me back and functioning sooner, I could see why some people would pay that. That said, I'm all with you. Like, if you have a plan, if you've exercised your DRP, if you know that you can get back on your feet quickly, just do it. Like, don't pay those jerks.
Yeah. And Mike followed that up, the question in a more general term of how you recover from a like industry-wide, he called it cancellation, more of looking at, and this was the example he gave was an intentional shutdown of a client by a cloud provider, probably for violation of terms of service or something. But I can even see this, not a intentional cancellation, but a the other side, your cloud provider goes out of business, right? So how do you deal with, this is your data recovery kind of built into some of these complete catastrophic? And I know we mentioned hurricanes and stuff, but some of this might even go beyond that because your cloud provider is now gone. What do you do, in that situation?
Yeah. And we're starting to see that a lot with our customers, the idea of what happens when a cloud provider goes down. And so a lot of our customers are starting to look at multi-cloud, rather than just being reliant on AWS. And I know AWS is easy, and so everybody is really bought in and adopted there. But a lot of our customers are starting to look at, well, what does it look like if I've got AWS and Microsoft Azure or Google Cloud, or even some of the smaller cloud providers where they have a little bit more personalization, and there's actually people there, right, that can help them out. And so that's become a big thing for us, is helping people figure out what does that look like for multi-cloud? How can I test actually cutting over and trying to operate on that other cloud provider when something goes wrong?
Yeah, I mean, has things changed to the point where, so I remember the days of, a data center, and you pretty much had a hot backup somewhere else running, right? And you could, if your communications went down or that facility had a power outage, this hot backup would kick right in. And I'm kind of wondering, have we kind of moved away from that hot backup in a cloud environment just because it's become so big? Have you seen that? Is that something you're addressing at all?
Yeah, I've seen folks generally that's still there. We always recommend that people have, replication in multiple, at least availability zones, but preferably in multiple regions, and again in multiple cloud providers. Multiple cloud providers becomes extremely difficult because there is no consistency between them. So having sort of a hot standby is still going to be really tricky. There's a lot of manual cutover. And so that's why, DRPs, again, they're not bad. You do want those plans, you want those checklists that people can follow, especially if you're looking at multi-cloud, because a lot of that is going to be manual. So having those steps detailed out on how to make that cutover is important. But that said, back to hot standbys, yes, like having replication in place. Replication has sort of replaced hot standbys because you can, if you've got replication, you can sort of use it all the time. So it's thinking that more as, well, if I have enough disks in my RAID array, do I really need a hot standby, right? If one disk out of 100 goes down, it's probably okay. So we're starting to see things more in that sense of how far can we replicate, how broadly, rather than having a hot standby.
Yeah, and to build off of that in the same similar notion, and again, I'm going back to the old metal days, I guess we'll call it, as opposed to cloud days. And the software was, you would put it away in a lockbox somewhere because you only updated it once every year or twice a year at most, so you could easily put software away. But in today's world, where you're doing software updates daily, if not hourly, having that up-to-date software is an issue. Is there anything that you want to say about that issue and how people are addressing it or moving forward?
Yeah, I mean, I guess I'm not quite clear what your question is here.
So it's more of, so there was a time when, so how do you ensure your software is backed up, I guess, when it's constantly refreshing, so to speak, as opposed to the days where you could, you had months to build a piece?
Yeah, I mean, I think that's an interesting question, right? Because as we move to faster deployments, most of your software is going to live in a repository somewhere. And so always having that current version and even previous versions, that is more available now. I think it does bring up the question though, if I'm using, for example, GitHub to store all of my code and GitHub goes down, and at the same time, GitHub's based in Azure, right? So if I'm using Microsoft Azure as my production infrastructure environment, and let's say it goes down and it takes GitHub down with it, maybe now I don't have access to my code and my production systems are down. That becomes an interesting case. And so again, I think, as people are starting to think of these larger reliability issues, that's where the idea of multi-cloud starts to come in is, well, not only do I need that infrastructure, I do need to think of where's my code repository? All that being said, Git works in fantastic ways. So hopefully there's a local copy on somebody's machine. And if you've got a development team, you'll have that available. But it is a tricky thing. And you don't want to be scraping that code from, figuring out which developer has the latest copy. So as you think of moving to multi-cloud, because, you might be subject to things, like Mike's question, you want to think about where your code lives, where are your tools? I mentioned that as you're starting to test with chaos engineering, thinking about those third-party tools. So it might not even be your your cloud provider or your Git repository. It could be, I think Mike's question mentioned Parler. They were reliant on Auth0, right, for their authorization and login. What happens when that goes down? How does it affect your systems? Do you have a backup in place for that?
Right. So Hendrik has a question here, and he wonders if there's any advice for balancing or prioritizing resource requirements, such as time for planning and testing of DRP versus other day-to-day activities. So to expand on that question, then, is DRP really run by or should it have a separate group that, or not even a group, just a few individuals whose job it is to deal with this? Or is it more of a can be done when you have time?
Yeah, that's a great question. I think that comes back to what we were chatting about earlier with having an error budget, having some time to really work on things and sort of separate that out from your daily responsibilities of working on reliability. So I highly, again, recommend that folks read the Google SRE books for more details on that. In terms of who owns DRP, I really like that model of service teams having complete ownership of their service. And so a lot of that comes to, well, if you're responsible for designing, coding, deploying, and operating your software or your service, you should also be responsible for the disaster planning, at least to some extent. That said, most organizations that I've worked in, the service team's responsible for that, but there usually is a larger cross-team guild or team, a team of teams kind of a thing, where those folks are the ones that coordinate the larger, what happens if multiple services go down. That's one of the things in that Qualtrics case study that I had mentioned. Qualtrics had a team that was tasked with chaos engineering. And so that team really just helped go to all the individual service teams and ensure that does your service team have a plan for what happens when things go down? Does it have a plan for what if your service goes down? And then as sort of a broader cross-team group, they were the ones that were able to help them plan what happens if your dependencies go down, what happens if services that rely on your service go down, and really coordinating all of that between the different teams.
Right. So is there for your the link here when DevOps disaster strikes, is that the talking a lot about the chaos engineering, or is there, if I want to just learn chaos engineering in general, is there a specific place in Gremlin to find that?
Yeah, I think that would be this. The best place to go would be this link, the gremlin.com/reliability. And that covers a lot of what I've talked about today, just general reliability, how to, build your systems to be more observable, have better monitoring, et cetera. But it also does cover that chaos engineering as well.
All right, great. We don't have any more questions, so I think we'll go through and announce our Amazon gift card winners and close this out a few minutes early, not many. We've pretty much used up the whole hour. But the attendees selected for the $25 Amazon gift cards are Hendrik M. And that wasn't because he asked a question. I got his name before the question even came up. Eric S., Timothy R., and Kenny O. So you will receive an email to the email address you registered for this webinar. If you're like me and have 7 emails, kind of got to figure out which one it is. But the email will explain how you can receive your gift. So please don't forget to check all 7 of your email addresses or your spam folder if you don't receive it soon. So I want to thank you, Jason, our sponsor, Gremlin. And as I've mentioned, for more information on Gremlin and how to use chaos engineering and helps you develop that resilient software, you can go to gremlin.com. But thank you, our audience, for taking an hour out of your day to spend it with us. And goodbye, and may the fickle finger of fate be kind to you.